Hello everyone. So today we are solving another question of JEE ADV 2015. This is on the topic of wave optics. So let's read the question. So in our YDSC experiment, or double slit experiment, the slits S1 and S2 is immersed in water in the refractive index of 4 by 3 as shown in the figure. The position of the maxima on the surface of the water is given by x is equal to, like, there is some relation where lambda is the wavelength of the light in air and 2d is the separation between the slits, and okay, these are the things here. So let's first draw an image with ourselves also, so that everything will be clear here. Let's suppose this is our line. These are two slits here, and I think you have solved this question using that kind of like some slab introduced in the front of the. This is a very similar question to like that only, but only thing is that they have put a complete water here. Okay, up to here. So this is water of refracting index 4 by 3. And if you have read about optic path and all, then if like a light travels in a medium of refracting index some mu, so the net optic path covered by that particle, that wave will be equal to mu times the actual distance. Okay. So if suppose the same particle travels some distance d here, and the same particle travels in this medium up to here only, so basically the optical path covered by it will be equal to mu d here. Okay. So this is the concept he used during the whole question here. So let me draw here, and I'll explain through this image only. So let's suppose at the x there is maximum. What is the condition of maxima in the YDSC? It is only when the delta x should be equal to, what is delta x? It is the path difference. This should be of the multiple of n lambda. Okay. So at any time when let's suppose this is our point of maxima. Okay. So when this point, I mean the path difference between this, if this is the path 1, let's say it as x1 and this is x2. When x1 minus x2 or x2 minus x1 is in the multiple of n lambda, then only it is possible that there will be a maxima here. Okay. So how we can write x1 and x2 by generalizing it? Let's suppose this distance is d, we know, and this is x. So what will be the path covered by the path 1, and it means x1? So x1 will be always equal to root under d square plus x square. Similarly, x2 will also be equal to root under d square plus x square. But where is the twist? The twist is that we have to cover the optical path. So we have to multiply it with the mu. So what is x2 minus x1? It is nothing but mu minus 1 times root under d square plus x square. Now this should be of the multiple of n lambda. Basically they have given m in the place of n here. So we'll write m lambda. Okay. Mu is nothing but 4 by 3 here minus 1. And let's square it both sides. So let me erase this diagram here. So what we will get is, this should be equal to 1 by 3 into root under d square plus x square. This should be equal to m lambda. Now if we multiply, square both sides, so we will get d square plus x square is equal to m square lambda square into 9. Okay. You can see that this 3 has been squared and moved to that side. So ultimately we get the equation x square is equal to 9m square lambda square minus d square. So let's check what they are asking. They are asking for the p square. So there is p square is nothing but 9. It means p is equal to 3 here. So let me write the final answer. So p is equal to 3 is our final answer. Thank you everyone.